Good afternoon, everyone. Any questions? All right, hearing no questions, I'll get going. I want to talk, before going on with the regular lecture, about homework 3, and there's just some basic thoughts about how to approach a somewhat more challenging homework. And so what struck me with homework 3B when I looked at, or the 3 final I should say, when I looked at the many Piazza comments, that I would look at the code and I would say, this code is so wrong-headed that the person obviously never did it by hand. That person started coding and then tried to beat the code into submission. And that is a strategy that works pretty well until about the end of 46A. And after that, the programming problems that you're asked to solve get to be so complex that taking wrong-headed code that you don't understand what it does and then try to beat it into submission by rearranging the various statements in it is a losing strategy. And how do I know that? So I know that because when you click on some of these links, you will find where someone says, I'm still confused over this after hours of solving. Or stuck on this assignment for days. Or been extremely stuck on this problem for days. And so if you are stuck on a problem for days that asks you to read in a bunch of lines of text and put them in an array and then see which of them start with an asterisk, then that seems to me that the people who are stuck on this for days are not using an optimal strategy of arriving at a solution. And so the most important thing in coding, yes?
Yeah, what I found helps me is like if you trace your code on paper and see where you can see where the errors are arising from, and that also helps you understand the code a bit better.
Right, but what I want to say is even a step before that. There's no sense in having code until you can do it by hand.
Right.
If you can't do it by hand, if you can't go through the input with a pencil and know exactly what you're going to be doing with every line of input, with every character of input by hand, if you don't know that exactly, then you're wasting your time rushing to code. And this is something that everyone learns, and almost everyone learns the hard way. That's fine, so I'm not complaining. It's just the way it always goes. But it is amazing how much more effective you could be by coding later and by first doing things by hand and by coding later. So, for example, if we look at one of the things that was difficult for many people, and rightly so, because I made these problems to be not totally trivial. Let's look at 3A here. Well, I mean, not look at 3A. That's not the point I'm trying to make. So I'm going to look at at 3B here, where so we'll have some input files, and so one of the things that's key in order to do something by hand. I didn't even get to see the input files. Oh, because I'm in the draft, I'm sorry. So one of the things that's key when doing something by hand is to have inputs. Now, you're super fortunate in CodeCheck that I'm giving you lots of inputs. So otherwise, students often find it very difficult to come up with good examples. But here, we do have loads of examples. So now let's say I want to do this problem by hand. And when I say by hand, I mean I want to have some strategy that I can execute on paper where I can have some variables and where I can, read into these variables and I can make some decisions. So let's say I have this here as my input file here. And well, am I going to read it a line at a time? Am I going to read it a word at a time? And if so, with what separators? So that would be a good first decision to make. What should I do? Okay, he says a line at a time. We'll run with that. Okay, so I'm going to read this thing a line at a time. And so I have my line is 9.1. Inheritance hierarchies. Now what am I going to do with this line? I'll see if the first character is a digit, okay? It is a digit. Now what should I do? So I store, what do I store? Do I store the 9? How do I find the 9.1? I could split it, that's a good idea. Or I could make a secondary scanner and do dot next. Okay, so either way, I find this word and I store it. Where do I store it? In a variable. Give me a good name for the variable. What's that? Well, give me a better name than temporary. Okay, how about section? Okay, so now section is 9.1. All right, so now I've read this line. Do I do anything else with this line? No, I'm done with this line, right? I have no further interest in it. I read the next line, and now in the next line here, I do the same thing, right? I split out, it starts with a number, I take it out, and now what do I do with it, with the 9.3? Well, I have to put it somewhere. So now you have a variable section, you have a variable new section, okay. Fine. So I put 9.3 in here. And then what? So they're in order, right? 9.3 comes after, so I don't have to say anything particular. So now I get the next one here, so I get this 9.13. Where do I put it? Aha! So what you say is, okay, I move this one in here, so that this one here now becomes 9.3, and then new section is 9.13. So at this point here, one has the basic parts of an algorithm that one can then start writing some pseudocode, and I'll talk about pseudocode in a minute. But so one has the basic bits and pieces of an algorithm that shows how to do this by hand. And now comes the big danger. What's the danger at this point? Oh, the big danger is that you say, oh, I have a basic algorithm. Let me just fire up Eclipse and type in what I have, and I'll wing the details as I run into them. That's the danger, because it doesn't usually work all that well. So the winning strategy is to first look at now all the weird inputs and see whether your basic algorithm can also deal with the weird inputs. So in this particular scheme here, there's actually only one set of weird inputs, and that appears all the way on the bottom, because all the others can be handled. So over here, now I have this one here, And so what do you do with a line that doesn't start with a number? I guess there you do nothing, right? And over here we have another line that it doesn't start with a digit. So the strategy of saying if it doesn't start with a digit, that seems to be good enough about handling our inputs. You know, it's a very good question. What if I had trotted out like numbers like this to confuse the issue, but I didn't. So, and no one asked. So we don't have to worry about it. So now we're ready to write up some pseudocode, right? So we can say for each line, and that's good enough. You could say for each line in the input file, but for each line is good enough. So if the line starts with a digit, then what was it? I guess now we have to say section equals new section. Was that how it went? New section is the first word in the line. So if new section comes before section, complain. Is that so? Let me test this one with one more example here. So over here, my first line is 7-1 arrays, starts with a digit. So I'm here. Section is new section. What the heck is new section? Oh, this is that. What do I do the very first time? So you want me to have a Boolean that remembers if it's the first time? So I could do that. So oftentimes, the first time is special, and so you have to worry about that as a special case. There's any number of strategies that you can use. One time-honored strategy is to have a Boolean first, and say first is true, and then we would say here, for each line, if it starts with a digit, if first is false, else, and then else we do all of this stuff. That way we don't do that checking, but don't I have to? No, I still have to do this, to do this part, yes. So, else, new section is the first word. Okay. Can I move this out? So really then in my next iteration, that I can't do that here. I would just move that thing out somewhere. All right, so and this pseudocode will work. Okay, it bothers me that I can't erase on this thing. Let me just waste a bit of time and do this one more time. So we say first, equals true for each line. So now so if it starts with a digit, now I've learned that I say next, what is new section is the first word. If first is false, else section Echt? Oh, I see. So I'm tying myself in knots with the new section versus the section. I guess I can always do that, and so what if it was blank? So else if section is after new section, complaint. So here I have my pseudocode. This is for what, 3B final, right? How many lines of actual Java code is this approximately going to be? I have a guess. Someone says 20, yeah. Maybe slightly optimistic, or 20, 25, in that order, right? Because, you expect that, there's a little bit of fussing around with some of these things, but by and large, it's going to be a loop of 20 or so. Once you have the pseudocode, how long would it take, someone who's gone through 46A to code this up? Really? Let's hope not, right? I mean, each and every one of those translates into very familiar Java. Okay, how long would it take me to do it? No, not 5 seconds, right? I can't type that fast. 5 minutes, yes, that seems about fair, right? I mean, this thing can be directly translated to Java, and there's 5 minutes of the original typing, then there's some syntax errors, there's one or few silly things that one didn't think about, and then it's done. But to go from here to a solution, I hope it's believable to all of you that it's not a matter of 4 days and saying I'm so confused. So the hard part is not to write the Java code. The hard part is always to come up with a strategy. And if you come up with the right strategy and you test that strategy a few times and you're willing to go through the pseudocode and execute it with a few examples by hand to get out obvious nastinesses like what happens the very first time, or what happens with lines that don't have numbers and that kind of stuff, and you adjust that on the level of the pseudocode, then it's not so hard. But if you rush to coding and then you get all confused by some random stuff that happens in poorly thought out code, then it's not so good. So I'll do another one like this. Come on. So if you think of the problem where you had to deal with these dots and these characters, and there were a lot of people whose actual code had this general shape. Those of you who spent the weekend looking at Piazza know what I'm talking about, right? And so this kind of stuff is super fragile, because if you somehow get in a situation where you run into the wrong loop and then something else happens. What if you had x dot dot and then an exclamation mark? But in this loop, you were all looking for dots, or these ifs, you were all looking for dots, and you didn't think of the exclamation mark. Or you might have to go into each of them and now put in more else's, because each one of them could have been one of those exclamation marks. And then you get into code that is very fragile. And so once you've written some code like that, and as a public service, I've made you write code like that once, you will never want to do it again, but you will want to have a different approach. And so the approach that works for this kind of stuff is, oh, by the way, I found a bunch of solutions that were cheating, and I wish I had thought of that and disallowed that. You were not supposed to read the file twice, right? There was a whole bunch of people who said, oh, I'm just going to read the file and count words, and then I'm going to read it again and count something else. And that's very ingenious, but that's against the unwritten rules for file processing. So the idea is when you do file processing, you should be able to do it just all in one fell swoop. Because there are many situations where you only get the file once, where it's gone afterwards. Like if it's user input from the console, for example. And there's always some people who say, oh, I just put the entire file in a string and then I process that string twice. But you can do much better. You can do it in one fell swoop here. So the idea is there some way of only reading one character at a time, and from that very myopic point of view, coming up with a solution? And so what you need is some kind of memory. So imagine that you are locked in a box, and all you can see is one character at a time, but you're allowed to remember whatever you want to remember. And then the next character comes. You're never allowed to look at the previous one again unless you've chosen to remember it. But so now you want to say, what do you want to remember? So it seems worthwhile to remember the previous one. Right? That way you can see if you have two dots in a row. And you can see, are you at the beginning of a word or something? And that turns out to be enough. So there's a basic algorithm for reading a character at a time and looking at the previous one. In fact, we've seen it with the section numbers as well. So so you have two variables, previous and current, and this while you have another character, you set previous to current and current to next or in.next, whatever. And now you ask some simple questions. If they're both dots. If previous wasn't a letter, and current is. If current is a exclamation mark, a question mark. And in each of these cases, it turns out you can do a very simple action. So if previous wasn't a letter and current is, what do? You increment the words because you've just seen the beginning of a word. When you've seen something that wasn't a letter, and then you see a letter, you've seen the beginning of a word, and that's what gives you your word count. When you're in the middle of the word, you don't want to increment the counter again. If the current is one of these special symbols, then of course you do the sentences. And then you need to figure out how to deal with the periods, and I'm going to leave that for you right now. But you can fill in this basic outline, and you're going to get a basic algorithm that will solve the problem. You can then go with a few sample inputs and try out whether the algorithm works on paper. And when you do that, you're going to get an algorithm that's reasonably straightforward. You've tested on paper. How many lines of Java will it turn into? Approximately 20, right? Maybe 25. How long will it take to code? I mean, 5 minutes, a couple hours. I mean, not all weekend, right? I mean, there's not a lot to it. But you have to have the algorithm first. If you have some basic thing that you think is kind of going to work, and then you try to whip it into shape by throwing the 7 test inputs from CodeCheck at it. It's very, very time consuming, as some of you have seen. I've been spending days with this problem. The only way to spend days with this problem is to code too soon. So that's a super common thing. And to try to resist the temptation to do that, because everyone knows that coding is a lot more fun than thinking, I'm really going to push the pseudocode thing for a while. So I really don't want you to waste your time like that. Yeah. So make sample inputs or get sample inputs. Sample inputs are incredibly useful because they tell you where the nasty cases are. You can't avoid the nasty cases. They always come in test cases 6 and 7. And so you might as well look at them before you start coding. I often read these comments that make me cry where it says, oh, everything worked so well for the first 2 test cases, but then these other 2 test cases, they're just mean. But I mean, that's not how the world is, right? You have to first look at all of the test cases that you know what is the universe of expected inputs. And no one input is meaner than any other. They're just all there, and you have to handle them all. There's no partial credit for handling, they actually is, but there shouldn't be, for handling like some of the inputs, right? Just imagine you're driving along in your computer-controlled car, and it handles some of the inputs correctly, right? It's not really good enough. So you have to understand what all of the things are that could be thrown at you, and you want to understand what you're going to be doing with them before you fire up Eclipse. There's no sense in firing up Eclipse if you can't do it by hand. You have to be able to do it by hand, otherwise don't do it. All right? So from now on, the golden rule in Piazza will be for a few weeks only pseudocode. At this point, you're old enough that if you have some basic syntax error, that you can figure that out. And by the way, we've covered after today, we will have covered every last bit of Java syntax that you will need for the next so many years. No more syntax. From now on, it's all algorithms. So it's all this stuff, figuring out how to solve something. And so we're done with syntax. And so the syntax errors that you get, presumably you can figure out pretty quickly. But the entire challenge for the rest of the course is, how do I do it? And if you can't do it by hand, then you can't do it at all. All right. The other thing I wanted to say, because I got a useful question in Piazza about that, is at some point you do need a code. And like there was a question in Piazza that had perfectly good pseudocode, and then it said, but still it's not working. And right now, no one can help you with this because you're not allowed to post code. What do you do? So if you have something where you are sure it should be working, you've traced it through, and you still can't find the error, first of all, it's well worth tracing it through one more time. But what happens if you've traced the code by hand several times, you can't find the error? What's the next thing? So you've read the code, you've gone through with your finger through the input, and you can't figure out why it's wrong. You say it really should be hitting that line where it prints something, and it doesn't. So if it gets hairy enough that you can't figure out with your brain, and these problems will get to that point pretty quickly, you have to be able to use the debugger. Everyone learned how to use the debugger in 46A, I hope. If not, put a thing on Piazza, and I will post the lab that they had for the debugger. You simply must do it on your own time. Somewhere between now and the end of 46B, you have to be able to use the debugger, not just on straightforward problems like in 46A, but on some pretty hairy problems. By the end of 46B, we're going to be doing some debugging of linked list structures and tree structures where you have to write down memory addresses and stuff. So be prepared to use the debugger for easy scenarios now. There was a screenshot that you had to make. Was there a screenshot of the debugger for the prerequisite test?
No.
No? Well, I'll make one for the next homework. So you have to be able to use the debugger. And so let me just do that in Eclipse, because the one thing that I want to show you is how to use the debugger when there's a command line argument. So this is the specific question that came up. So I don't care if we don't get to the lecture. I want to show this. So I believe the question came up in the context of 4a, a beautiful question, by the way. And so one needs to read these things here. But there's a file, and then one gets to read it from the command line. Let's see, do we have any starter code? Oh, well, that's very generous. Here's the generous starter code that we got. So let's run Eclipse. So, and I'm showing this because I want to make sure that you realize that CodeCheck is good for what it is, but as these problems get more complicated, you have to learn to live between Eclipse and CodeCheck and use them both for what they're good for. So we'll make a new project. Java project is fine. This one we can use the default location because we have nothing. So this is homework 4a. New class salaries. Okay, now it puts it in a package. Because I wasn't paying attention. So let's put it in the default package. I don't want this one. I don't want the package. All right, so all right, so now we get a scanner. New scanner. File name. As next line. What the? Oh, has. Line equals next line. Okay, now what am I supposed to do? Find all the digits in it. Oh. I need to kill the dollar signs and commas. All right, so here's one other trick that's kind of useful, and that is it's of course rewarding to have all the pseudocode worked out. But if God forbid you don't, like I don't have right now because I'm shortcutting this here, let me solve a simpler problem first and just print the sum of these last things here, okay? So an easy way to get at those last things is to split. And then the very last number is tokens.length minus 1. Oops, I need to parse it. Now I need to find the sum of them. and when I'm done, I print it. All right, so here's my little program. So let me run it. And it doesn't work. So I guess I should post it on Piazza now and say, it's just not working. So what's happening here is I'm getting in line 6 here an error. Let's find out why, line 6. Because args0 doesn't exist. So if I launch this on the command line, then I could say Java space salaries space and then the name of some file, and then it would work fine. And that's normally a perfectly good way of testing it, but then I can't use the debugger. So what I'm going to show you right now is how you can run the debugger and specify the command line argument. So first of all, I guess I should make a file. And I should be able to put it into the same directory. New file. And I'll just call it in1.txt. I'll copy all of this stuff here. And now I wanted to read from in1.txt. So the way you do this is you have to make a run configuration, and in the run configuration, in the program arguments, you put the name of the file. And now it must have read it because I get an entirely different problem. So I no longer get the, let's see what exception I'm getting. I'm getting a number format exception. That means it must have read my file, because otherwise I would have gotten a file not found exception. So what I've just done, and I'll show it to you again in slow motion in just a minute, will have done the trick. So again, what did I do? I went into run as, run configurations, arguments, and over here I put in the argument that I would normally type on the command line. That way when Eclipse launches this program, it'll launch it with that argument. So remember this, or remember it happened at 20 before 4, so you can look it up in the video again. So now I have this program misbehaving, and I could run it through the debugger. So let me just do that. So I'll start debugging. And there's two kinds of debuggers. There's the ones that are kind of nice and that wait at the beginning of the program. And then there's the ones that's not so nice and that just starts running. Which of the two do I have? This one started running right away. So it just started running, and now it has died. My program has died here in integer.parseInt with an exception, and it doesn't have the source for it, which is just fine. I didn't want the source for integer.parseInt. So that's not so nice. So I'm going to terminate the program and run again. So in this case, I should set a breakpoint. Oops. In the first line of main, and then I run the debugger. Okay, where do I do this? Okay, I have my breakpoint, so I'll run the debugger. And now my program is here in the first line of main. Now I can do step over, and now I can look at the line. And okay, where do I see the damn line? No, I haven't read it yet. That's why I don't see it. So I'll step over it, and now I can see The line says in1.txt. Huh? What did I do wrong? I did make a new file. Excellent. So I was supposed to have put a new file, file name, and I need to import file. Now, so remember there's two scanner constructors. There's the one that takes a file, and then it reads what's in the file. And then there's a scanner that takes a string, and then it just reads what's in the string. So the string literally said in1.txt, so it read in1.txt, and that was not completely useless. That wasn't what I wanted at all. Now this is the kind of mistake that if you're not allowed to post this code on Piazza so that someone can tell you, you knucklehead, you were supposed to put in a new file, where I find it very difficult to see it with my own eyes. And that's where being able to fire up the debugger is really useful. Because for the human eye to see these kinds of little things, is challenging. But once you're in the debugger and you see that as soon as I knew, the millisecond I saw that line was in1.txt, I knew what my mistake was. But until you actually see that, I thought my mistake was something different. I thought, and in fact, there is another mistake because I didn't treat the first line differently. But so the debugger is super useful, and you really want to know how to use the debugger. On a personal note, when I had my first programming job, I was still a student. I had a programming job. And my manager said, only sissies use a debugger. Real programmers read the hex dump. Because at the time, when the program died, it would write the entire memory. There wasn't as much of it as there is now, in hex. And he was able to read through that hex dump and say, oh, here's the data, here's the program, and he could read the assembly output in hex, and here's where you made a mistake. I said, that's crazy. And with my own money, I went and paid for the debugger. At the time, you had to still buy those things. And it was several $100s, but it was worth it within the first week. I saved so much time by doing that instead of reading the damn hex dump that I cannot recommend any other way. So you want to learn how to use the debugger. In this particular situation, this is how to get it to run with the command line input. All right, so now I've frittered away this entire thing on stuff that's actually much more useful than the lecture. So let's see if we can salvage anything from the lecture. So I'm going to tell you in 15 minutes or less on what exception handling is all about. Exception handling is useful and it's necessary. There's two things that you need to know. The first thing is, suppose you're writing some piece of code, like some method in a class, and something goes really wrong. That in that situation, what you should do is you should throw an exception. What you should not do is you should not print out a warning. You should not set an error code. You should not return null. If you're in a situation where things are really bad, blame the caller and throw an exception. No one can overlook the exception. This sounds cruel, but it actually is very effective. And this happens in Java. What happens when you call get and the index is out of bound on an array list? Do you get a warning on the screen and your program keeps on running? Does it return null or an empty string or 0 or some such thing? No, it throws an exception, right? That way it's impossible for you to overlook that there was a very real problem and you've got to fix it. So when you code something, you should do the same thing. So in I believe it's homework 4C, in the final version, you're supposed to do the very same thing. When you find an error, any kind of error at all, don't try to limp along, don't try to keep on going, throw an exception. you would expect nothing less from the Google car that you're driving, right? Or that's driving you. Something weird happens on the highway, it'll just throw an exception and you're terminated. No. I mean, of course, at some point, one also has to catch those exceptions. So I'm going to skip some clicker questions here. And I'll go back to the checked exceptions in a minute. So at some point you have to catch exceptions. And so you'll see the syntax in the book. It's straightforward. You have a bunch of code that does some stuff. Any of these lines could do something bad. Or maybe there's a method that you call that calls a method that calls a method, and something bad happens 4 levels deep. And eventually you say, okay, enough with these IO exceptions. I'm going to do something about them. Here, this person doesn't do much about them. They just print a message. Here, they print another message, so also not a great remedy. But at this point, the exceptions are caught. And that's reasonable. You can also, and that's a very common thing, you can simply have the exception get thrown a level out. So here I have a process method. It takes a file name, and it presumably opens the file, processes the file in some way, closes the file, and harvests whatever information. Now, of course, it's possible that that file name is not valid, and then the opening the file would fail. Now, this particular process method decided that if that happens, the process method is going to do nothing about it. It's simply going to let the exception escape further out. And that's a normal kind of thing to do, that exceptions don't have to be handled right away, that you normally want the exceptions to just happen and then they get handled at a higher level. But in Java, perhaps unfortunately, there are 2 kinds of exception. There are the exceptions that you've seen all along: index out of bounds exception, null pointer exception. And those are called unchecked exceptions, as opposed to this exception that you have here, the IO exceptions, which the compiler forces you to either handle or acknowledge. So here we say process can throw a file not found exception. Nothing wrong about it. You're simply advertising it. This method might do that. Could process also throw a null pointer exception? Heck yes, every method can check a null pointer exception. Null pointer exceptions are not checked. And why the difference between these 2 exceptions? The idea is that a file not found exception is the fault for the file not being there may not be the programmer's fault. Whereas the null pointer exception is always the programmer's fault. And so programmers are supposed to figure out their own faults without the compiler helping them out in this way. But with these external things that can always happen, programmers should be put on notice that they need to track these conditions carefully. So from your point of view, what that means is that if you put in new scanner of some file, you need to worry about what happens to that file not found exception. In almost all cases, the correct way of dealing with it is to simply tag the caller and say, let it throw. You can even do that in main. You can say, oh, main might throw this exception, deal with it. So main might die. There's nothing wrong with it. It's a little bit of extra tedium. Let's see. I might come back to the clicker questions depending on how much time I have. No, I don't want to do this. Okay, I don't want to talk about okay, yes, I do want to talk about this. Going back to the Eclipse thing, someone asked on Piazza a while ago, why is it that every time I have a scanner that there's the light bulb here? Are scanners somehow dark things that need a light bulb to illuminate them? Yeah, so here we didn't call in.close, right? What happens when you open a file and then you don't close it? So they tell you in programmer school, right? They tell you you're supposed to close all the files that you open. So what happens if you read from a file and then you don't close it? You're a bad person. That's what happens. All right. So in fact, in this day and age, with reading from a file, nothing happens. If you just read from a file and you forget to close it, it's okay. What happens if you write to a file and you forget to close it? Pay attention, because this will happen to you and you will want to know. Yeah, what happens actually? No, that's only in Windows. No programmer uses Windows, so we don't care. But that's actually true. In Windows, it might lock the file, and but in any operating system, what can happen? So you write to a file and you forget to close. Now, someone says it won't actually write to it, and that's not quite true. Because what it'll do, when you look at the file editor, it'll usually write a little bit to it. Because eventually, the way that writing works is it buffers the output for a while in memory. Eventually, the buffer gets full, and then it gets thrown to disk. And so what you usually get is you get an incompletely written file. And so when you see that, then you'll know and say, oh, I forgot to close the file. But of course, that's bad. So with writing, closing a file is important. When you read something from another resource, like from a database connection, it is super important that you close those, because a database has a very finite number of connections. So if you have a web application and a user walks up, your application opens the database, gets some information, and then forgets to close it, a few 10,000 users later, and your database is completely hosed, because it could not sustain that number of open connections to it. So closing a connection in general is very important, and so the light bulb is right. You should just not be a bad person. You should be in the habit of always closing. Now, closing is harder than you think. So here I have some code where, so this should be indent. So, I'm reading from a file. I don't know why I'm doing it in this way, but I am. So I'm reading from a file, and then I forget to close it. No, I don't forget to close it. I actually do close it. Give me a scenario. Here it says may never get here. Why does it say may never get here? Give me a scenario where this close doesn't get executed. Yeah, say the file was not found, right? But that would be okay, because in that case we never opened it in the first place. There's no harm in not closing a file that we never opened. But is it possible that we execute this line, so that the file is open, the scanner is open, we're calling this line here, this line now has been called, but then we don't get here. Exactly. If read data throws a null pointer exception, say, then this would not be closed. So ideally what you would have to say is fine, call read data, and then catch whatever exceptions it might throw, close the file, and then rethrow whatever these exceptions might be. And so that's what the finally clause is for. And here is what you saw in the book. So it says you do a try finally thing. And this was in fact what you're supposed to do until 2 or 3 years ago. And then they changed the language to say this happens so commonly that there is a better way of doing it. And I just want you to do the better way of doing it. This is the last time that we're using this edition of the book. We're switching to the next edition next semester. And the new book has the better way of doing it. So what I want you to do is, whenever you have this light bulb, is to use this try with resources statement. So let me explain to you the statement, because you probably didn't read it. It's in a special topic in the book and easy to overlook. So forget about try finally. There's a good chance you won't need try finally ever, but you will need this try with resources all the time. Anytime that you have a resource that needs to be closed, like in this case here, the scanner, you declare the scanner inside the try block. So it's try, parenthesis, resource inside here, and then the braces and the body inside here. And then you don't have to call close. Close is automatically called for you when the try block is left in any old way. If execution is normal, it gets closed. If there was an exception, the resource also gets closed. The technical condition is that the resource needs to implement the closable interface or auto-closable interface, some such thing. So let me do that here in this code. So all I do is I put try. Then I have to take the semicolon out here because it's now a part of the header. And then I put a pair of braces, one here. And one here. And then I'll reformat everything. Here we go. I need to change the formatting. So here you have the try block with the scanner declaration and this stuff in here. Oh, I guess this stuff needs to be in here. And so every time that you use a scanner or a print writer, I want you to use this form of the try with resources statement. So when you see that light bulb from now on, make sure to make that light bulb go away. It's a cheap thrill.
So can we start from the final service assignment?
You can start now. I mean, if you already submitted it, it's okay. But certainly from the final. And, I'm not sure that I'm going to make the grader check for something like that. It doesn't seem worth it. But it's a really good idea to keep the code free from light bulbs. And so this is the way to do it. Yeah.
About an exception, when you're designing something like a lot bigger or program,
Yeah.
when do you know to throw an exception, or when you be passing them up the kind of chain?
Yes. All right, so having anticipated this question, here's the slide. We actually arranged this before class. So how do you design with exceptions? And that is a super good question and people do tend to be confused about this. And there's really two simple principles that that you should follow. The first one is there's no shame in throwing an exception. When people first learn about exceptions, and they learn that when they throw an exception, the program will die, they say, oh, well, I'll never throw an exception. Why would I want to kill a nice program? But the truth is, the program will not die. You can catch the exception and deal with it later. But it's almost always makes the code much cleaner that if something is very wrong, if you simply throw the exception. Because that way, the problem is impossible to ignore. In the past, before there were exceptions, people did this all the time, that they would have a method that did some work and it also returned an error code. True means it was successful, false means there was some kind of an error. And it was really tedious to use those things because you had to call the method and check the error code. And then you had to, if you found an error, you had to yourself return an error code. And people would just not check those error codes. They just never did. And so error conditions would be overlooked. And so then some error would be there. It would be overlooked. The code would keep on running. Many thousands of statements later, something bad would happen. And it was then very difficult to trace back to the errors. There was a time when hardware didn't have the kind of protection that you have now, so you were able to access all memory everywhere in the machine. I'd have students who would write into array locations where they didn't exist. They would then overwrite a part of the operating system. And really terrible things would happen, thousands and thousands of instructions later, and was impossible to debug. So an exception is great. If no one catches the exception, the program dies with the stack trace. You can see in the stack trace exactly what the source of unhappiness was. So by all means, you should always throw an exception if there's anything that you feel is not worth continuing. Or you should cause the exception to happen. So there's some people who check every parameter, like you have some methods with parameters, and then they check whether they're null. Don't do that. If they're null, someone was stupid enough to give you a null where they wasn't supposed to give you a null, let it crash. So that's the right way of dealing with an exception, an exceptional situation, is to, at that point, not to continue in a bad situation, but just let someone know. So there is two things that, there's the one decision that you make at that point, namely, what exception should you throw? And in general, at this point in your career, your first strategy should be to try to pick an appropriate exception class. Illegal argument exception covers a wide variety of sins. Out of bounds exception. One of those kind of standard exceptions, there's a whole list of them that you can choose from. These are all good. Like, which one do I sometimes use? Illegal state exception, no such element exception. Usually one of those standard words describes your situation well enough. If you feel that you should do better than that, you can certainly design a custom exception class. You're going to be doing that in one of the homeworks. I give you an example. And that way, one can be a little bit more specific about the cause of that. It's not a bad idea. Now, should you throw a checked exception or an unchecked exception? And I would say until you've done quite a bit more design work, at this point I wouldn't throw a checked exception. Checked exceptions are tricky things. Programmers do crazy things with them. And it's not clear whether they were actually a good idea. So I would throw an unchecked exception of either an appropriate class if there is a dead-on match for what you want to express, or maybe a simple custom class. Now, the other hard part about exceptions is people feel that they're calling this method. This method might throw an exception, and they should do something about it. And you shouldn't. So when there is an exception, you should generally just let it fly by. You should only do something with an exception if you know what actually should be done about it. So if you know how to handle the exception in a meaningful way. Let's say that you're programming the part of the user interface where you ask the user, what's the file name? And then the user typed in a bad file name. That's a good point to handle a file not found exception, because you can ask the user. But if you're in a situation where you're doing some intermediate level processing, a file name was given to you, you don't know where it came from, at this point you may not have a user to ask. And at that point you should just let that exception happen. So the rule is throw early, catch late. That's the golden rule of exception handling. And if you do that, then you generally have a good interface design for exceptions. All right, so now I do have a time for at least a couple of clicker questions, so let me find the best one. What's that? No. You almost never catch in the same method in which you throw. Well, you catch where you can constructively handle the exception. So there's no sense in catching any earlier than where you really know how to cure the cause of the exception. So, like what I say, if you have a file name that's bad, there's no sense in catching it until you can figure out what to do with that information. Do you ask the user for another file name? Do you save all the program state and bail? Do you retry something different? And at that state where you can take effective action, that's where you catch the exception and you take the effective action. In practice, that's not usually hard to do because you know from the structure of your program where you can take that action. You ask yourself, if this happens, what action do I need to take? Where do I need to take that action? And that's where you catch the exception.
And you're saying on the same side, just throw everything and throw a lot of exceptions?
Yeah, when something is wrong, you're better off throwing an exception than try to come up with some remedy. It's almost never the case that the remedy is going to be as useful as throwing the exception. So throwing exceptions is normal, and one simply has to realize that there's there's a possibility of situation that some subsystem does something bad, and you need to be prepared for that. So you have these horror stories of that there are rockets that some part of the machinery throws some exception. But with a rocket, I mean, what's the alternative? That it crashes into a building? I mean, you have to be prepared for it. Exceptions prepare you for it.
So the main method there was an exception.
That's fine. That has happened to some of you.
Who gets it?
Why would you catch it?
Well, we just don't.
Let main die. I mean, you're better off having main die, and then you look at the stack trace. This has happened to you usefully many times. Maybe not to you personally, but to me, right? I mean, you write something, you have a null pointer exception somewhere. I'm happy when main dies with a null pointer exception because it tells me exactly where the cause was. It's much better than if you catch the null pointer exception and then you say, what are you going to say? A null pointer exception has occurred. I'm very sorry. I mean, that gives the user no information, right? But if you let it crash, then you get the stack trace. So, yeah, psychologically it feels wrong, but that's the way it is. You want to have exceptions happen. They give you good information. An exception is a great way of going from the point of problem to the point that can fix it. That's what they were designed to do. All right, well, I guess now we've talked this to death, and I'm not going to give you any clicker questions. It is a shame. They were all great questions. So what I really do want to get across is for this homework, if you could please try it my way, write the pseudocode, get it to actually work on paper, and then when it works for you on paper, then you go and code, and you'll find that you can save yourself hours of useless labor. How do you write good pseudocode? Your last question for today. How do you write good pseudocode? There's only one way to learn how to write good pseudocode, and that is to write bad pseudocode first. So I expect a lot of very bad pseudocode on Piazza in the next few days, and you learn it by experience. Put your bad pseudocode on Piazza. I will try my best to decipher every